We're looking at homework problems for multiplying and dividing algebraic fractions, exercise 2.9. I'll just make that a little bit bigger. Okay, the first thing we need to do is factorize any expressions that can be factorized. Now this expression up here, 3 is a highest common factor between the 3x and the 12. So we go 3 bracket what? 3x plus 4, then over 12 times 8 over x plus 4. Now as I said, no cancelling unless there's multiplication symbols. Now this x plus 4, just put it in a bracket. Put that x plus 4 in a bracket. That way the whole of this, because that's 3 times bracket x plus 4, and this is 1 times bracket x plus 4, these x plus 4s can cancel because you put them in brackets. Okay, and then we've also got some cancelling with the 8 and the 12, or the 3 and the 12 if you want. Okay, so you can do the cancelling here. You don't have to if you don't want to. 3 times 8 is 24 over 12, which happens to be what? 2. So I just multiplied because I could see 24 over 12 is going to be 2. Okay? Using out this 6k plus 42, what's the common factor, highest common factor? 6 bracket k plus 7. So you're really hoping for the k plus 7 in brackets here as well, which you will get. What's the highest common factor with the 5k and the 35? 5 bracket k plus 7 over 18m. So what's going to cancel, girls? Everything's multiplied because we've got 5 bracket k plus 7. So the k plus 7s can cancel. There's a time symbol here. So that means cancelling can happen. So the k plus 7s cancel. Look, you can do some more cancelling if you want between the 18 and the 24, if you want. Otherwise, if you feel it's getting messy, you can just go straight to the next row. What can we do with the 18 and the 24? What goes into both? Which times tables?
3.
Higher. 6 times tables? So we've got, or you can go to the next row if you want. I'll go to the next row if it's getting too messy. So I've gone to the next row, now I'll start cancelling. Okay, we've got 6 times tables with the 18 and the 24. So 18 divided by 6 is 3. 24 divided by 6 is 4. You can do some more cancelling with the 4 and the 6 if you want. What's 4 sixths? Anyone? 2/3. So you can do it there, or I can just put it on the next row. 2/3. What's going to happen with the m's? You can write them out. Look, I'll just keep going. So all I've done is cancelled out done some cancelling with the 18 and the 24. Now we can do, and I've cancelled out the 4 and the 6 to make it 2/3. You okay with that? All right, what have we got now? What else cancels? One of the m's. So I'm going to take the squared off here with the m there. Do you get that? So what have I got on the numerator? 10m over 9. So girls, you can do more cancelling in the one place if you want, but if you're finding that it's getting too busy, too messy, you don't want to lose marks because you can't read your own writing. All right? Another homework problem, question 8F. So we need to factorise out each of these 4 expressions. They can all be factorised. So what can come out of the first one? What's the highest common factor? A bracket A plus 2. Right, the denominator. What can come out? 21. 21 goes into 21 and 21. Bracket x minus y times highest common factor 14. X minus y. It's looking good. Already the x minus y's are going to cancel, and if you're lucky, you're going to get an a plus 2 down here. That'll cancel with this a plus 2. 5 is the highest common factor, a plus 2. So girls, once you start seeing some factors, you're sort of hoping that you'll get the same factors elsewhere coming out as well in those brackets that can cancel. How are we with that? So what can cancel, girls? Heaps. I'm just going to do the x minus y's and the a plus 2's, and then I'll just go to the next row. What have I got on the numerator before I... Yeah. Do you want to do the 14 and the 21 now as well? What goes into both of those? So we got 2 and we got 3. So what have we got left? With 2 times a is 2a over 15. And remember, when all these other things cancel, you're left with ones, not zeros, ones. This last one here, just to save, writing, why don't we factorize and flip in the one step? So what's the highest common factor of 18a and 27b? 9, bracket, a minus, it is 2a, thank you, 2a minus 3b. So that's a 2a, girls, if you can't read it. Now I'm going to change my times to a divide, and I'm going to flip. So the 35ab squared goes on the bottom, okay? And I'm going to factorize this while I'm here. So factorizing the 12a minus 18b, what have you got? 6, bracket, 2a minus 3b. Are you okay with that, girls? Changing the divide to a times, flipping, but I'm going to factorize. Otherwise, you've got to write the whole lot out again. Are we good with that? So I've factorized that, but done the flip at the same time. And we've got some cancelling, the 2a minus 3b. You can do some more cancelling there with the 25 and the 35. What goes into both those? So I've got 5 and 7. If you want, you can do more cancelling with the 6 and the 9. What have you got? 3 goes into both those. I think it's messy enough already. I wouldn't be doing any more cancelling. So what have we got with the numbers? 5 times 2 is 10. We've still got a squared b over 3 times 7 is 21. And you've got ab squared. All right, so just be careful, girls. And of course, when these other things cancel, you get ones. So just make sure you can read your writing. 10 over 21, I don't think that can be factorized. And what's going to happen with the a's and the b's? What are you going to be left with? 1a where? On the top numerator. And a b on the denominator. All right? Because a squared b is a times b. And ab squared is a times b times b. One of the b's from the top cancel with the bottom. One a from the top cancels with one from the bottom. Some other problems. Exercise 9.3, question 18. Does anyone remember what to do with this? If 3 to the power of x equals 5, evaluate 3 to the power of x plus 1. Do you remember what to do with that? 3 to the power of x plus 1. Where do you think you got that x plus 1 from? Those indices have been added. So the bases must have been the same. That came from 3 to the power of x times 3 to the power of 1. Because why did they do the x plus 1? Because the bases were the same. You're sort of working backwards. And x plus 1 is x plus 1. That's where that came from. Now, what does 3 to the power of x equal? Because the question is, if 3 to the power of x equals 5, evaluate 3 to the power of x plus 1. So we say 3 to the power of x plus 1, those indices have been added. They must have come from this. 3 to the power of x times 3 to the power of 1. So now we substitute 3 to the power of x equals what? 5 times 3 to the power of 1, or 5 times 3, which is 15. And the other questions in there are 3 to the power of x plus 2, for example. Do you know what to do with that? For example, 3 to the power of x plus 2 is just what? 3 to the power of x times 3 to the power of 2. Okay? All good? All right. So the next one, are we done? Can I move from here? Part B, I think it was 3 to the power of x plus 2, I think. 3 to the power of x is 5. 3 squared is 9. 45. Okay, someone else had a problem? Homework problem, exercise 9.4, question 10. And the question is a quarter of 2 to the power of n in index form. Now a quarter, see girls, we've got 2 to the power of n. We've got a base 2. Let's try and make the quarter, write it as a base 2. Isn't that 1 over 2 to the power of what? 2. So a quarter is 1 over 2 to the power of 2 of 2 to the n. Now girls, how can you write? I can do this a couple of ways. I can just multiply numerators, multiply denominators, or, and if I do that, That's over 1. I've got 2 to the power of n over what? 2 squared. No, just keep it as 2 squared, because the other thing you could have done is written this as 2 to the power of negative 2 if you want. But yeah, wait a sec, we're not finished. But do you get what I've done so far, girls? Okay, good. Girls, bases are the same and I'm dividing. What do you do with the indices?
N minus 2.
You subtract. Okay? Now, the other way you could have done that, so we can go this way. The other thing we could have done is go like this. 1 over 2 squared is 2 to the power of what? 1 over means what sort of power? Negative. This was the other way you could have done it. So you could do it like that, where you multiply numerators, multiply denominators, and then we use the index laws for dividing, which means subtract the indices if the bases are the same. The other way you could have done it, or you could have said, I know that's 2 to the power of negative 2 times 2 to the power of n. Girls, here we're multiplying, so you add the indices, negative 2 plus n or n plus negative 2. We like to put the pronumeral first. So I can write that as negative 2 plus n. Girls, we don't like to see the negative. That's the same as plus n minus 2 or n minus 2. Okay? So you could have done that both ways, using the division law for indices or using the multiplication law for indices. Okay? And using the negative law there. So either way.